Okay. All right, we can have our panelists sit down over here, and any order is fine, actually. We'll go ahead and get started with our last panel of the day. So we're going to kick it off first with a talk from Shatel Bhakta. He's the lead architect for the Lunar architecture team for NASA's Artemis enterprise. He leads multidisciplinary teams across NASA centers in the development of the lunar architecture and Artemis Base Camp, and their associated mission planning, ConOps, site planning, trades and analysis, system element conceptualization, and system of systems integration. Shatel earned his undergraduate degree in mechanical engineering from UT Austin and graduate degree in space architecture from University of Houston. Over 20 years of experience in human spaceflight program development and operations ranging from ISS, Orion to Gateway. So I'll go ahead and you can come on up and have your talk. Thank you very much.
Thank you. All right, thank you very much. And for those of you that know me or don't know me, I'll pretty much respond with anything in how you pronounce my name, as long as you get it within the ballpark. So some of you may know me as Shatel because you cannot get Shatel out of the way it's spelled. Others know me as Shatel, and we'll go from there. A lot of the materials that we're going to talk, try to make it quick just so we can keep going. Pam and Spuds have already covered, so I'll try to just go over those pretty quickly so we don't get into those details. But I did want to talk a little bit about, didn't ask which button it was to advance.
So it's the left and right buttons, and point them at the clock roughly.
Okay. There we go. All right. So we've already seen this slide, so I won't spend too much time on this. We've got the national posture, the science, and the inspiration. Those are the three pillars that we're working towards. There we go. All right. We've seen the blueprint, the wireframe, how we're working on the goals and objectives to cycle back through the architecture. And as you see, integration at the bottom, the feedback that we're requesting from industry, from our partners across the globe, is really the key to this, and this will be what makes this slightly different than what NASA has done in the past. And the goal here is to get more stakeholder buy-in across the spectrum into the architecture. Something that may not have been as widely disseminated, but is within the ADD and some of the products that go with it, is the whole architecting from the right. So on the right, you see the objectives and goals. This is very similar to what we would do in a typical systems engineering process. And so what we're looking at is moving over to the left, looking at our functions, use cases, segments, and sub-architectures, a lot of which you heard Pam talk about. And the key area where we're looking for participation is going to be in that area towards the left, right? We've got stakeholders that have already been working with us on the objectives and goals. And what we want to do now is with industry, academia, and everyone else is work into the functions. So you've got the first introduction to those functions at a very high level, focused mainly on HLR, the human lunar return. And what we're going to be doing over the course of the next few ACRs is refining those use cases and functions, which is appropriate because that's a lot of what we're going to discuss in this panel coming up. All right. This is an eye chart, but for the most part, what we're trying to show you here, similar graphic there on the right with the objectives and goals. But as you see, there's an integration across the directorates. The ACR that we held earlier this year was one of the first times we've gotten broad engagement across the centers and across the directorates in order to be more aligned. So this is the unity of purpose that Spuds alluded to and that we're trying to go for, not only at one level, but across the agency. So that way we can use interactive, the robot-human interactions is a big key, but as you can see, it touches all of the directorates. So it's not tied to just the human spaceflight and ESDMD. Now, the ACR, the ADD, those are a focus of just the human spaceflight aspect. So JIM, STMD, SMD, they're doing other work that doesn't necessarily fall within the purview of the ADD and the ACR content. So if you don't see it in our materials, that doesn't mean it doesn't exist within the agency. It just doesn't mean it's considered a major part or an enabling part of the human architecture. ACR, we've talked about it. Again, we're planning to hold those annually in November, making sure that we're refining things. We're not putting everything out there in one shot. We don't expect that anything that goes out there is necessarily baselined or set in stone, as the saying goes. What we want to do is take contributions, take feedback, and iterate, evolve, and scale based on technologies and what's coming out. All right. Again, some of the questions you can ask as you're developing and laying out an architecture, going through systems engineering. Why? We've got the three pillars, and then some of the things that we're looking for. What foundational capabilities are needing? Where are the systems and where should they be? How will we get there, and when will we return? And then when do these objectives get met? Will they ever be met? If we do our jobs right, the objectives will also change with us, and we won't ever meet the objectives, but we'll get to completion of certain ones or near a completion on some of them. But the whole goal will be to look at those objectives, measure how well we're doing to those in the architecture, and then reiterate the cycle and refine what we're doing, what we're looking for, what functions are needed in order to accomplish those objectives. And as Jim kind of jokingly told me when I asked him, when we're done with the moon, I'd like to go to Mars. He said, no, because we're not going to be done with the moon. So that's a good message right there, I think, for everybody. So we've talked about segments and sub-architectures at a high level, so I'm not going to say all the words here, but we're trying to break this up into chunks. The segments can be temporal, but they overlap, as you'll see in the next slide. And the sub-architectures are similar to the subsystems that you would see in a typical system or system of systems. We expect, or I expect, that we will be changing those, and they are evolvable depending on what stage that we are in the architecture. So once we set these, it's not that we won't revisit them, add to them, or subtract from them as we mature things and as the architecture develops. This is just a graphic to show you the cool hardware that's there. Human lunar return, obviously, most of these systems and programs are in work now, and we've heard about them or seen some of their successes happening. So this is a similar approach that we'll take for the next two segments, and finally the humans to Mars. Graphic that most have probably seen before in previous iterations or versions of this, just showing a little bit more temporally how we would expect those segments to lay out and overlap with each other. All right. Public products, again, I'm not going to go through this. You've seen the QR codes. There's three main documents that are out there, three main groups, the ADD, the glossy, and then the white papers, which we are definitely looking for feedback on all of those, as well as topics that you would like to see in the future that would need expansion on. Pam didn't talk about this slide in detail, but as we're talking about areas for collaboration, these align fairly well with the sub-architectures that are laid out right now. Obviously, we're reevaluating each of these areas, but for folks looking for collaboration, these are some of the main areas and groupings that we'd like. As you can see, ranges from subsystems like power and CP&T to logistics, which is a major component of us being on the lunar surface for prolonged periods of time, and then lunar sampling and curation, amongst other things. Okay, and opportunities to engage. We definitely want to hear from you. There's going to be different forums that'll be available similar to this one. There'll be agency workshops as well as workshops with professional societies. We definitely want to hear from you. We're not saying, promising that everyone will be happy, because if I'm doing my job right, we'll all kind of be a little bit upset with each other, but we'll be moving forward, right? That's the big thing. We should be moving forward to the goals. All right? That's it. I didn't want to take too much time, so Wes, hand it back to you. Thank you.
Thank you very much, Shatel. So I'm going to introduce all the rest of our panelists, then they'll each get a question, and then we'll move on to more questions from the audience as well. So as usual, use Slido to go ahead and give us some questions for the audience. So this is This panel is really aimed at the long-term use cases. In a sense, it's a bit of a microcosm of the architect from the right and execute from the left. So we have people basically representing across that entire pathway here, and we'll get questions on their perspectives for that. So I'll start with our panelist who's online. Carla Haroz, who's an Antarctic Operations Manager for National Science Foundation. She worked in mission control, though, for ISS for 23 years, and for the past year and a half has been NSF's Operation Manager for the Antarctic. So this is a fantastic perspective. We've talked a lot about, the science outpost and what are the technology needs and the infrastructure needs that we'll take to get there. So Carla will talk about that. Then over here, we've already heard from Shatel. Next to him, we've got Tim Cichan. He's a space architect at Lockheed Martin. He leads a multidisciplinary team of engineers who figure out how to help astronauts and robots visit the moon, asteroid, and Mars. Fantastic job. Next to him, we've got James Mastandrea, who's our own APL's LSIC Interoperability Working Group lead. Some of you also know him from the power focus group, surface power focus group as well. James has been a part of the LSII and LSIC team basically since the kickoff, right? So great to have him on board as well. We'll be talking about interoperability perspectives and how that can enable our long-term presence. Next to James, we've got Kristen. Kristen John, who's another familiar face to the LSIC crew. She's the Technical Integration Manager for Lunar Dust Mitigation at NASA JSC. And you gave such a wonderful talk about long-term implications of dust at the Survive the Night workshop, so we had to have you here giving your perspective again. Thank you. And then next to her, we have Kristina Gibbs, who's the SSERVI Deputy Director. So thank you very much for coming. Kristina Gibbs joined SSERVI as Associate Director and then assumed the position of Deputy Director in February 2020. But her experience goes all the way back to Mir Space Station supporting biological experiments. So great diversity of perspectives on this panel. Very excited to have you talking with us today. I'm going to stand up here and moderate so you guys can get all the attention down there. I'm going to give each of you a question that more or less goes along the lines of what's your perspective and why are you on this panel for long-term use cases? But I'll try to tailor them for each of you on the panel. So we'll start over here with Shatel. So NASA's laid out an exciting plan for architecture developments. What do you see as the critical areas where the industry and the community can support what you see in that achievement of a long-term presence on the lunar surface? Asking you to neck down, I know that's difficult. You'll press the button on it, and then you should be able to go live. Yep, there you go.
All right, there we go. All right, so the easy answer would be go back to that presentation and look at those 12 or 13 areas. But realistically, it's going to be some of the things that we've talked about, right? It's how are we going to operate together? How are we going to interact together? Not only here on the ground as we prepare for things, but definitely in space and on the lunar surface. So to me, that's one of the biggest challenges, is to make sure that the systems are ready for that, and that we know as we're moving forward that it is sustainable, not just from a financial perspective, but from economic perspective. Is there a reason to go? When we're going there, are we being just and taking care of what we're doing? And then are we leaving the moon in a situation where we can keep going back and in a safe manner, an effective manner? So.
All right, Carla, going to you online, I want to make sure that we are getting questions to you as well. How does the unique environment and constraints, how do unique environments and constraints drive infrastructure and technology needs of a remote scientific outpost? And what do we need to know now in advance of our long-term arrival to support that long-term success that we want on the lunar surface?
Hi, thanks, Wes. Thanks for having me. As Wes mentioned, my name is Carla Haroz. I'm the U.S. Antarctic Program Operations Program Manager, but I was at NASA in mission control for 23 years prior to that, so really well versed in NASA. There's quite a bit of lessons learned to be taken from the long duration space flight missions such as ISS and our operations at our 3 stations in Antarctica, and both have unique constraints because of their remote environments. So obviously, in both cases, it can take a long time to talk to the ground or back to the US from the stations, and you might need to make a command decision on how to repair something or stop an emergency. And our crews have to be prepared to handle these issues and situations and fix things themselves on their own. If there's one thing I've learned after 20 years of mission control is that not everything will have a procedure. You can't train or prepare for every situation. There's always something new that springs up that no one thought could possibly happen. So our crews and teams need to be resilient in how they handle issues on their own without guidance from the ground. For all the stations, you have to plan in advance for food, fuel, waste, trash removal, resupply, have spare parts at the plenty. There's no Home Depot or grocery store around the corner. Your crew or cargo resupply ship could be delayed by a pandemic or a global crisis. So at USAP, US Antarctic Program, we plan for cargo and fuel years in advance, and at ISS, we do that as well. So things to think about there. You need to be planning on regenerative systems, such as the Regen ECLA system we have on ISS, taking the urine processing and changing it into potable water, thinking about robust redundant systems that can take over when the prime or even the backup system fails. Especially for Antarctica, we need to use our environment of the location to our advantage. So for example, in Antarctica at McMurdo Station, our largest station that has about 1,000 people, we build an ice pier to handle offloading of cargo vehicles. So a pier out of ice, we use what we have. We built a runway that a airplane as heavy as the C-17 can land on, made out of compacted snow. We had to take the environment into account, such as the cold weather hardening of equipment. We have special fuels for Antarctic weather. We have to take the lifetime of the fleet and the vehicles into consideration. You know, the older the part is or the vehicle is, the more maintenance that will come to that, and we don't have the luxury of bringing those vehicles back to work on them. So if I could say anything, we don't underestimate the amount of maintenance time you're going to have to do. Maintaining equipment takes a lot of just as much time and effort as the science, if not more. Just another example on USAP, we have snowdrift to worry about, maybe something that's similar to the lunar dust. Each season at the South Pole, we are constantly digging out away the snow from buildings, and we even have the station at the South Pole is built to be elevated as the snow builds. Just little things to think about here and there. Let's see, what else can I say? A lot of things to say about thinking about outside the box that I might be able to answer some other questions and give some time to the others, but
very good. You know, it's very much a fire hose of all the things that we know that we.
I have a whole bunch more. There's lots of corollaries between
It's fantastic.
ISS, long duration space flight, and Antarctica. So.
Okay, great. Well, and honestly, as these questions evolve, if other panelists see, you know, places where a conversation can develop from there, that's what I think we really want to have in this time. So Tim, question to you. How do you see industry posed to solving these issues of long-term presence that have just been posed, but now for the lunar surface? And what do you need to know from the rest of the community to help you on your way?
So the thing that I'm most excited about, and we just saw it in the last 2 days here, is that we've got this great diversity of companies working towards sustainable lunar infrastructure. Companies, very small startups, very innovative, all the way to companies like mine, which might be on the bigger side. And we're focused on services. We're not necessarily designing widgets anymore. We are working on services. So we're working on developing the technology to do those services, as well as the business to be able to do that. And I think that, you know, as we're working towards those goals of the objectives that Pam and Spuds talked about, that really focuses us. And there's all of this competition and collaboration happening at the same time, which I think that ecosystem, that economy that we're building is really going to allow us to be successful. And we're working on that too. We just started a new services business called Crescent, which is a small, lean organization that's going to own and operate services, starting with communication services. And they're going to be able to leverage the bigger Lockheed Martin space in those technologies in the spacecraft. But we have that focus on infrastructure, you know, and same things that we need in Antarctica, same things we need at home. We need, you know, the family car, we need the cell phone coverage, we need energy, we need fuel. So we're working closely with power, both from a VSAT and an FSP perspective. And also when we need to all think from a vision perspective, what's the long term, and then also, you know, act today tactically. Part of my job, which is really fun, is to think of the vision part. And, you know, our vision is a nuclear-enabled water economy. So making propellant on the surface of the moon for use in cislunar, for use in Earth orbit, for use going to Mars, going beyond, and then leveraging nuclear power, because that is such a great energy source, whether it's stable and compact. Who cares how much sunlight you have, constant power, that's game-changing. And of course, nuclear thermal propulsion, where you've got high efficiency, high thrust, all at the same time, and using that water-based propellant. From a needs perspective, I think that we all need to know what everyone else is doing. Those are our customers out there. There's possible collaboration partners. I think we also all need help with technology development, just like STMD is doing, and other customers, both from, hey, we need a little help with the technology, but also that's an excellent demand signal. This is what our customers want to develop and what they want to buy in the future. And then the last part is how are we going to behave on the surface of the moon? And it's not just domestic, it's also international. It's the whole community. So I'm on an organization that the Moon Village Association started called GEXLA, which is Global Expert Group for Sustainable Lunar Activity. GEGSLA, so you can go Google it. We've been working the past 2 years, international group, Artemis Accord nations, and China and India and Russia. And we work by consensus, and we've just produced a document of recommended norms of behavior for the lunar surface. We're starting to publicize that document and starting to engage at the UN. So that's one example. AIAA and the Aerospace Corporation are starting cislunar task forces, again intended to be an international group of industry and academia and space agencies working together. And eventually this is going to lead to interoperability and standards. But right now it's a little early, so we're trying to figure out how all of those things go. But so, diverse services economy, partnerships all around, and then, working for sustainable technology.
Very good. And so now we've heard some of all the things that we need to know from Antarctica and outposts. We've heard the technologies that are going to be developed. How are they going to work together, James? James, the interoperability lead. How do you see these investments towards interoperability enabling that long-term lunar presence?
Yeah, so I think these early investments are critical. When I think about the term enduring lunar presence, I think about the community. This does not be one organization, whether government or an international partner or one commercial entity. This will really be everybody going back together to the moon. And I think you have to design interoperability into that system so that everybody who's a part of this ecosystem can see themselves in that architecture. And I think NASA has done a great job in doing that, and I encourage folks to look at those documents, right? When you also think of the enduring lunar presence, you think of the infrastructure, you think of the habitation, you think of the transportation that is needed and how it'll all work together, right? We need to make sure that there are low barriers to entry for other commercial or international partners to join, right? So if we develop standards with common interfaces and modular systems, it'll enable new companies to then plug into these new systems, just as here on Earth with various, computer peripherals or other analogies that you can see that enable new companies to join and plug into that. And I would say that the time to start is really now. Now that we have developed these early architecture decisions, we'll start having these discussions now about what are these critical interfaces? What can we decide as a community need to be standardized now? Perhaps I'm biased, I come from the surface power group, but everyone to a certain extent will need power, right? So I think it's important that whether you're on the lunar surface or if you're going from a lunar asset down to the lunar surface, down to your transportation vehicle, the astronauts have the ability to charge their phone or whatever devices that they are allowed to have with them as they explore the lunar surface. And so I think there's interoperability that we need to focus on the lunar surface, but also in the lunar ecosystem. And I think the more that we can do now, the better, because if we wait too long, I think all the various stakeholders will continue to proceed with their internal R&D and we'll end up having many solutions to the same problem that won't be interoperable. And then we could suffer problems that if things change, companies come and go, we'd have different needs, right? We don't have consistent standards in place that will survive past any one organization. And we need to make sure that it does survive past one organization to benefit all.
Thanks, James. So now we've heard how we're going to all work together. And now, Kristen, can you tell us how dust and other things that you would consider in the long term could bite us, even if we make our systems work together? Some perspectives, maybe something that scares us from from my perspective. Dust is both this big, scary monster and something that we can actually address.
Yeah, absolutely. Thank you. I totally agree. I think dust mitigation is a great way for the community to get involved. It's a great part of LSIC. So obviously I'm biased towards dust mitigation. As I talked about at the Survive the Night workshop, it's really kind of a confluence of things coming together. So when we think about surviving the night, for instance, and you know, that's just a couple of days compared to real sustainability, which will last much longer. But even in surviving the night, you have thermal considerations and power considerations. But when you think about adding the dust problem into that, just from Apollo alone, we know the effects that that had on power systems and thermal systems. And so, you know, we were just there for a moment. So I really think the dust issue is a concern that every project, every hardware that goes to the lunar surface needs to be thinking about. So specific to dust, right? Anything from, you know, landing pads to paved roads, you know, sintering roads, that sort of thing. I think for, you know, sustainability, long-term stays on the surface, we'll need to consider. Even from a human health perspective, that, you know, things that we learned during Apollo and even the limits that we've set for the safety of humans as far as hazards from the lunar dust, that's going to be totally different when they're staying in a habitat for a longer duration. And so moving on away from dust, other things to consider are, of course, power. James mentioned that. I think having, you know, reliable power sources, being able to, energy storage, even portable energy, this is going to be critical. And then thermal is a huge thing that we have to consider also, and that's, you know, part of kind of maintaining the power systems and whatnot. Mobility, I think, will be key for sustainability. Also maintainability. I think the ability to maintain all of this hardware. And again, that comes back to the dust for me, thinking about maintaining hardware that's been exposed to dust, but just also stuff that needs to be maintained for other reasons. And then interoperability, of course, for sure. And then I think also construction infrastructure is something we have to consider if we're trying to grow a lunar base, for instance. And then just one thing I'll throw out there as well, I think, is you know, lessons learned from each visit to the surface. So I think, you know, looking at the swoosh chart that we saw that had all the different CLIPS missions going to the surface, each one of those CLIPS landers and anyone else that goes to the surface, I think we're going to learn a lot about the dust and about, you know, how to keep our hardware there for longer stays. So I'll leave it at that for now.
Great, thank you. So now that we've solved all the problems, including the pernicious lunar dust, Kristina, maybe you could tell us about some of the science drivers that could utilize large-scale science outposts on the moon and key technologies or policies that would enable us to do that science now and in the future.
Yeah, thank you. I don't know if that's close enough. Yeah, I guess my big message is don't forget the science. When you're planning and building, like, please think about it early and often. He mentioned my time with NASA goes back to the Mir space station, building out the ISS. And for many people, it was about, we got to build the power systems. We absolutely do. We've got to do all these things. And then, oh yeah, they want to do science. We need resources, we need all those powers, but when you're thinking about how much power, we need to be thinking about how much science is going to use. The science community can envision an entire module of equipment and storage and resources, data, for completing in situ analysis of all the different regolith and dust. We have researchers that want to put large radio telescopes on the far side of the moon. We have an unimaginable amount of work that can be done up there. The biological and physical sciences are going to want to grow plants, and plants take light. And they're doing amazing work at building light systems that use very little light or power. But we need to accommodate all of this work so that we can truly understand and build. One of the premises of, well, the main premise of SSERVI is that science enables exploration and exploration enables science. And it's a continual loop. And so we just have to make sure that all of those resources are in the planning. And so a couple things I want to point you all to. The architecture documents that have been talked a lot about today have, and in addition, Pam Melroy mentioned that we want to do this for the science. And so the very beginning of the objectives in that are all the different kinds of sciences that NASA wants to do. And I highly encourage you to think about how those would be used by your company if you were to provide an infrastructure or a service, whether it's an instrument or actually something on the surface of the moon for a long period of time. The other thing is that there's a Artemis science definition, Artemis 3 science definition document, which really goes into good depth about some of the work that the planetary science groups would like to do. So if you really want to get a sense of the kind of work that could be done, those are some really good resources. And then the Lunar Exploration Analysis Group, League, also has a really good resources and a lot of documents available for the community to understand. So I'll leave it at that, but I'm just going to end with, don't forget the science, please.
Fantastic, thank you. And I mean, that's a great way to sort of kick this all off. You know, we have clear things that we are trying to get out of this long-term presence, including extraordinary science like we could never do before, as well as those exploration goals that we've heard so much about as well. So a reminder, get questions on Slido if you have them. I don't know if, Jody, you've got some that are coming along. We'll start taking them up. But maybe I can start with a question while Jody's getting those ready. You know, we've talked about a lot of different communities here, so maybe starting with, let's start with Tim. How do you see the international community and other communities remaining aligned and engaged across all of these disparate objectives and goals? You talked about the water economy, nuclear-enabled water economy. You know, we've heard about science objectives as well. Maybe you can talk a little bit about how those are intersecting. And if you want to chime into the conversation, please, as well.
Yeah, I think from an international community perspective, we need to think about having them here with us as much as possible. And certainly the virtual capabilities make it a lot easier. The way Gexler worked is we worked virtually for years, and we had 2 or 3 in-person meetings, and that's great. So maybe there should be an LSIC international meeting at the next IAC or something like that. As far as, you know, science is the mission that we're talking about right now. And we need to keep our eyes on that and have an open conversation around what needs to be done and what services need to be and what needs to be done and what services, and have that back and forth with the whole community, everyone talking together.
Fantastic. So somebody make sure we write that down, because, you know, we pride ourselves in the LSIC as being able to respond to community calls. So that very much sounds like the type of workshop we could take on in the future. Other thoughts as well? Happy to take them. Yep.
Yeah, and I think from internationals, obviously, with the agencies, right, we can interact directly. That's always a great avenue. And then from industry and commercial, right, there's avenues for that as well. Hopefully, you know, the ADD and the information that's out there provides some locations for partners, especially international partners and industry partners that don't have a current venue with NASA or a voice. And then hopefully, as we expand with some of the societies that we talked about coming up in the summer, that we'll have this more open feedback cycle that we can then participate and have that iteration. So,
Go ahead.
Yeah, adding on, SSERVI has a strong international partnerships program. We have 11 partners in addition to our research teams that have their own international relationships. But one of the things that's come out of that is the European Lunar Symposium, and we're looking to expand that to other parts of the world in our partnerships. And there is a meeting in Padua, which is very close to Venice, Italy, at the end of June. And so if it's something that you're interested in understanding kind of some of the research that's being done and who the players are, it's another opportunity for the community to kind of engage and to understand what is being done above and beyond in the U.S. So I just wanted to kind of put a plug in for that.
Great. All right, so Jody, have you got a question that you could give us from the audience?
Yeah, I know I saw Carla's hand up earlier, and so I just
Sorry, I
wanted
was
to make
looking over
sure
here.
that.
Carla, go ahead. You can chime in too, please.
No, that's okay. I just kind of want to mention something I don't think I heard on the panel so far. To talk about stowage, like I know in ISS, stowage is a huge issue. We have a whole module dedicated to stowage. In Antarctica, we have decades of things being buried by the snow that hasn't gotten off the continent. So I just want to keep that in everybody's thought. Stowage and waste trash removal, of course, it's going to be different from the moon than it would be from ISS or from Antarctica, but that is a huge deal for both programs that I've been involved in.
Yeah, and that's such a fantastic lesson for us. You know, we've got so many things that are going to the moon. How do we leverage each one of those to bring the things that we need in perpetuity?
I was just going to add cold stowage, because in Antarctica, they kind of have that built in. They can just kind of throw it outside. But when we get to the moon, we really need cold storage for not only storage on the moon, but return of samples. So that's really going to be important.
Yeah, there's logistics issues. We really need to focus on those, whether it's waste or stowage or, you know, the supply train to the moon. And that's what we're trying to set up at all different levels, from the very big to the very small.
So that actually aligns very, very well with the question here on Slido. So I'll kind of repeat it and maybe open it up to the entire panel. How is reuse and salvage of property to enable long-term activities accounted for in Antarctica? So that'll be for Carla. And then do you think it will be dramatically different for the moon?
Well, what I can say for Antarctica, there are parts there that have been there forever and that we reuse on different vehicles, et cetera. We have personnel that if we don't have a part down there, we have people that can make the part. We have welders, we have carpenters, you know, we have mechanics, we have plumbers, electricians, all sorts of different backgrounds down there to help create things that we might need that we might not be able to have, that we don't have at the ready down there. So I think with the personnel we have, that's the way we're able to do it in Antarctica.
Anyone else want to chime in from the panel? How's it going to be different still?
I'll chime in. So I think with what we talk about iterative and evolvable, right? I think the state of the architecture would be, as we get to that point of being like McMurdo, hopefully, right? We have a large presence for science, that we'd end up needing a similar model, right? Where we'd be able to have certain parts available via logistics train that would get transported to the surface and be available. But if it's not, then some of those facilities to be able to make parts and or, you know, be able to make solutions by the members. But I think we have to be open to a different concept of that, and also something that evolves over time. Nothing that will set today that will be exactly what it is, but work from an incremental, similar to what we did on ISS, work by sending everything and then eventually having to work on recycling, eventually working, but you have to keep that in mind as we're putting the first steps together.
And I can imagine a situation where, hey, as robotics and autonomy advance, that ability to reuse spacecraft, to reuse the landers that are on the surface right now becomes a possibility. I think for crew, the crew's mission for a long time is going to be focused on that science and exploration. But if we have robotics that can drive up to a now dead lander and turn it into something else, that's where we're starting to operate in a manner that's sort of this new era of exploration, much more akin to what we do on Earth.
I guess I would just add that, you know, thinking about the importance of how you design and build your system so that you do take the end into account, right? So there's a severe mass cost penalty for launching anything new into space. So the more that you can design from the start to be reusable, the more benefits you could have, and the more that you could potentially repurpose once you get there, I think is something that would benefit the whole community.
Yeah, I think in the initial phases of design, right, looking at how it can be used through the entire life cycle because of the high cost of getting to the surface, right? It's something that everyone should factor in, whether it's modularity and parts can come off, or as we've seen, keeping the electronics and batteries alive through the night in order to be viable for use for different systems in the future, even for a revisit or something. So definitely a factor in how we can reuse it, because we don't want to have a lot of things littering the surface that are taking up space and also very expensive landmarks for us. So.
Jody, have you got another one for us?
Sure. So this one is for Kristina. Do you think some of the big science endeavors that will require significant large-scale observatories, do you think they'll help drive some of the needed development?
Absolutely. The more we can define now, the better off the requirements can be defined. I was told this morning that there is a lunar strategy that is coming out, whether it will speak directly to observatories. That's, one of the many things that researchers want to do from the surface of the moon, whether it's studying the moon or looking out at the universe. And so that onus goes on to the science community to be able to define these kinds of research more. But without that currently in place, and the documents I've talked about really outline those. Ben just reminded me earlier, at SSERVI, we put together an annual report every year. It's the work focused at SSERVI. But if you were to download those from our website, you would see the spectrum of types of research that relate to lunar exploration, and you would really get to better understand how many different kinds of research the community wants to do on the moon, and get a sense of the resources that would be needed until there's actual pen to paper. Now, I'm sure that there are groups within NASA that I'm not affiliated with that are doing some estimates and putting some numbers down and things like that. But as you all build out your technologies and infrastructure, it's something to really be taking into account as well.
Yeah, some examples, right? The Endurance A mission is about taking mobility and going long distance and then tying into the human infrastructure, right, to get those samples back. And so that's an early one. But if we're talking about building on the moon, building observatories, then we need materials, we need power, we need robotic construction. And I think that absolutely is going to drive our capability.
Yeah, and we can't underestimate how much we need from comms as well. We need to be able to get data back, because a certain amount of samples are going to come back, but there's going to be a lot of in situ work done on orbit, and we need the data to come back in a fairly quick timeline. It can't be, days or weeks or months. It's got to be hours.
Yeah, the data pipeline to the moon is pretty tiny right now. And,
Yeah.
and just the humans showing up and wanting to take video is going to be a big driver. But then when we were like, the kind of data that comes off an observatory, that's huge.
Yeah, so build that bigger, please.
Yeah, I think,
Go ahead.
Sorry, yeah, like you said, the humans obviously were going to be a bandwidth, but as we saw, a lot of the objectives are on science, right? So I think science and the baseline, requirements for comm is going to be a big thing that we're kind of looking at. And then obviously we've got the leg systems and the LCRNS that will help with that, but that's one of the things that will definitely be a focus for architecture in the next couple of years, to make sure that we're addressing those science needs. So I think that'll be a good thing to compare estimates of what those data needs would be, to see how close we are to each other, and obviously working with SOMD and SCAN as well to try to develop what the architecture need is there. So.
Yeah, I guess the only other thing I would add that's kind of from my past is, and it's been touched on, is the maintenance. And as time goes on, things need more maintenance. But the more you can spend time thinking about how to simplify the maintenance, the better. Because we saw, by the time Mir was ready to be sunsetted and brought back into the Pacific, they were spending so many hours each day keeping it in orbit that they couldn't do the science. And so they all go together. The more you can make interchangeable, easy to fix systems, the better the whole process works. So it's also something to factor into the planning.
I didn't want to steal your thunder, but the thing that I thought of that comes to my mind when you talk about the unexpected maintenance costs is the reactor that was at McMurdo. So I was wondering if, Carla, you have any sort of thoughts on other sort of heavy maintenance items that we need to be considering, either for potential for autonomous maintenance or other things that, if you could just automate some portion of that heavy person cost, what would those factors look like? What would they look like?
Goodness. Okay. I would say it's a little different. In McMurdo, we have a lot of heavy equipment, heavy machinery, cranes, snow plows, just big equipment, and they are constantly being battered by the elements there. So they're constantly in the vehicle maintenance facility. So if we had more robust vehicles, that would be helpful to have more time for the mechanics to be working on other things. But that's a heavy hitter. Like I said, we spend a lot of time on maintenance because of the elements.
Yeah, that's something that we're really working on understanding here. We want to put down infrastructure. That's going to be a lot of things operating for a long time on the moon being killed by things like dust and so on. So very good lessons learned for that as well. Maybe another question from the audience?
Sure, I'll try to distribute things as much as possible. There's a good amount of questions for Carla, so maybe if we run out of time, we can send you those questions and hopefully get the answers back to the audience. But we do have one here that I believe is for Kristen. So what keeps you up at night about dust?
Yeah, that's a great question. I think it's, just making sure that folks are thinking about it. I think being here, being part of LSIC, I know you guys are thinking about dust. But, we have dust mitigation efforts and projects underway, but any project, any effort that's going to the surface, whether it's Eclipse lander, Eclipse payload, HLS, anything, you're going to need a dust mitigation strategy. And so I think it's really, kind of making sure the word gets out there that folks need a plan for the dust, and even more so when we're talking about long-term use cases on the surface, maintainability, just thinking about the maintainability of the assets in Antarctica, that's going to be huge on the lunar surface. So I think that's probably the big one, is just making sure that folks are thinking about dust mitigation. So.
And more than just thinking about it, like putting the requirement in.
Sure.
So on VSAT, there are specific requirements. How are you going to address the dust? And as we design things like the lunar mobility vehicle for the surface, and when we can see the Apollo rover images of the dust flying everywhere. We know it's a problem. We know what they had to deal with. And as the energy of the systems goes up and the capability goes up, it just makes the dust worse.
Yep. And I'll throw in there too, even just testing. I think, I'm excited for the Lunar Proving Grounds workshop this summer, but just preparing for what you're going to expect on the lunar surface. We know a lot more, or we've developed a lot more testing capabilities and simulants and whatnot to test with. And I've also seen, exponential increase in folks actually testing their hardware with dust just in the last couple of years. I think a few years ago, Viper was the only one doing dust mitigation testing, and now we've got folks everywhere. So it comes back again to the lessons learned. It's, share as a community, both, within NASA and then industry and academia, as we're testing our hardware and understanding the tolerances of systems to dust. Share those lessons learned with the community, because everything we know from Apollo is qualitative based on astronaut quotes. We don't have a lot of quantitative data yet. So
Yeah, we definitely need more test facilities for dust at thermal vacuum. And if someone can invent one with lunar gravity too, well, that'd be great.
I will plug the University of Central Florida has built one with some gravity offload, so no, it's not exactly what you want, but they do have a large test bed that they just created with a little bit of gravity offload. So that's a new facility, SwampWorks. At Ames, we have a test bed, and they all kind of service different types of work. And I think there's a handful more. I don't actually have the full list. I think there's groups out there that are trying to develop them. But do look into them, because those test beds do, at least some of them exist right now. Viper's doing a ton of work in ours just optically right now.
Jody, have you got another one for us?
We do. Okay, this one's for Carla. How hard would it be to operate at the South Pole if you had to import your own water? So in other words, how important is ISRU? Do you think it's optional or required?
So we've been doing what's called rod wells since the 1970s, basically drilling a hole and getting the water out of the hole. And once that hole is depleted with the water, we fill it with waste and cover it in South Pole. That's been done since the 70s. And before that, they used snow melters. So we've never brought in, that I know, brought in our own water. I can say, you know, bringing cargo there and fuel there, to answer another question that's online, is another thing for flexible thinking. To bring in cargo and fuel on an LC-130, which is a C-130 with skis, is expensive. And the LC-130 brings in, uses a lot of fuel, like 2/3 of the fuel that it's bringing in to leave. So there had to be some flexible thinking about bringing in fuel and cargo on what we call a traverse, which we have a bunch of tractors that drag these fuel bladders 1,000 miles between McMurdo and South Pole, and that is cheaper and faster to get everything there. So I'm envisioning the person who asked me about the water, we wouldn't be dragging that water. We could if we had to, but we would use, go back to the snow melter if we had to.
Just to kind of like continue on that thread a little bit, how much of, you know, your ConOps and the technologies that you're leveraging now to like have to do less of those expensive things, how much of those really kicked off and were, you know, you understood them because you were actually operating and learning those lessons sort of live?
Well, I feel like there were a lot of people that were in the program and worked these issues and came up with these ideas over the decades and through their hard work and research and development and planning out like the route for the traverse, et cetera, and looking into fuel bladders and just different options. That came about because people had been around the program and had seen places that could be improved upon and had worked hard and made suggestions for these improvements.
Yeah. Jody, are there more questions we have online? Got some time still.
Yes, so let's see. I think this one can be sort of for the entire panel. So as the profile of an astronaut and space crew expands, how are we designing for this in our habitat and tech structures?
Why don't we start over here? Let's say that.
Can't speak for industry. The NASA standards obviously look for the percentiles, right? So the standards that are in our design standards look for the 5th percentile and the 95th percentile to be able to fit and operate within the systems. So those are usually requirements when those systems are deployed that are part of the enabling of diversity in our crew selection.
Yeah, and I think that having those types of requirements is important so that everyone can participate. And we designed to those standards on Orion. And I remember the CAD pictures of the 5% astronaut and the 95th astronaut next to one another. And was like, just looking at that picture, realized the diversity of people. But from a technical perspective, it affected the CG, it affected how we planned, how the crew worked. And so we absolutely have to accommodate as much as we can because that diversity of people and participation is important. I think as we talk about these problems, we need to go and we need to fly and we need to be there and we need to learn those lessons and quickly put them back in.
I see Carla still has her hand up too, so you can come off and.
Yeah, just real quick. I know we're talking about closer to now, but in the future, if we have a colony of people, if we have people like in Antarctica, right now we have military, we have contractors, we have scientists, we have heavy equipment operators, plumbers, electricians, et cetera, janitors. There's a colony in the future. I just really want people to think about not only the infrastructure that we're talking about, but what I think is the number one aspect of long duration space flight that we need to focus on is the human, the effect of the distance on the human. And we see that in our stations in Antarctica. I think people need to be thinking about the crew, the team, the colony, how to ensure there's a positive community and high morale in the future for our space flights.
Good. Did I see a hand up? No? Okay. Jody, do you have some more from the audience?
Oh, sorry, I'll just comment. Yeah, I think when we think of architecture, right, and from a technical and engineering standpoint, we do think of that more of the systems engineering, the systems architecture, but Carla's point, I think, is valid, right? When
We're still working on, how much volume is the right amount of volume for someone who's going to be in space, right? There's a lot of studies done with human factors as far as color schemes, right? What kind of shared space is viable? Do you really, you need certain separation, certain private space requirements, things like that. So I definitely agree with that, especially based on the durations and the extreme environments that they're being asked to go through. So definitely things that we should factor in as the architecture matures.
Yeah, and maybe you're going to say this point too, but I was thinking about the amount of humans interacting with the architecture that's going through these different phases as well is really critical, right? So if we have autonomous operations, which are doing a lot of our infrastructure, and then have to come and interact with humans, how does this work out?
And there might be unexpected things. One of the things on the Orion PDR was how big is the medical kit? And how much mass do we allocate? And the risk to the crew of having a medical issue in a far off place was a real big driver. And as an architect, I didn't really think about that. But we really need that human-centric design when we're flying with people. Is a difficult topic, and especially as we start thinking about Mars or a year on the lunar surface, it's a big deal.
Yeah, aborts, incapacitated crew. I mean, those are all functions that we definitely want to make sure address the different phases in the architecture, right? There's obviously fault tolerance and other things, but basic things have to be accounted for as far as first line contingencies and that. So, yeah.
All right, very good. So we've got just a couple minutes left, and I'm sure there's more questions from the audience, but I think I'll start with a question, or give a final question to the audience. We're changing things. Things are different now for our return to the moon. They're different now even from the last time we tried to go to the moon. So maybe you could give your perspective on what you think is most different about this return to the moon. We'll start in the middle with James, and then we'll work ourselves around.
Sure, that's a great question. A couple of things come to mind, but if I had to choose one, I would really consider, the impact of what your products will have throughout its entire life cycle, right? We've talked about architecture, we've talked about maintaining that architecture, but I think as the panel has echoed, right, repairability and maintenance will be critical, and you will not have the ability to go get parts readily. So I think many times when we talk about technologies, we're always trying to optimize for that one technical area, right? To have the best power system, the best power converter, et cetera. And I think as we have started to see, I think an equally important figure of merit on all of this technology is how resilient is it to dust? How reliable is it? How easy is it to maintain, fix, repair? How modular is it such that whether it's humans or robots could easily fix these parts? So I think that just adds a little bit of a difference when you are designing these systems about how you evaluate your technology. So, yeah.
Kristen, we'll go all the way around, starting James in the middle and come back. Yeah.
Okay, great. Yeah, for me, the big difference is the length of time. We were hardly there for Apollo, and so just thinking about the impacts of dust when we're there for surviving a lunar night, or wanting to have a lunar base and being there for days, weeks, months, years. So just the impact of dust and what that will have, and even kind of going back to what was said earlier about reusing parts, that sort of thing. I'm just imagining that, right? If you actually did have parts that you could use or take from another asset, you're doing that on the lunar surface with dust in your environment. You're going to be inducing dust in the area where you're doing maintenance, where you're doing, changing things out and building things. And so again, I don't want folks to underestimate the impacts that the dust will have on your systems, especially as we're there for long periods of time.
Kristina.
I think there's so many science questions out there that every group would say their question is the most important. I think for this group, ISRU is a really big one. And I don't know how much Apollo honestly was looking at that, but we really need to be figuring that out for future and what we can do, what Carla was saying, what we can use that's there versus having to bring it. So I think that'll be really important.
Great. In my view, the next person I see is Carla.
For me, I'm lucky that I was a Capcom with all the crew that's been selected for Artemis 2. And I think, to me, what's different is the diversity of the crew is exciting. And now that I'm not in NASA and I'm in SF, I can see other people's reactions outside of NASA. And I just think that is what's different, and that's what's important to me, is that we have this diversity of the crew and excitement in the population.
Fantastic.
I would say that we have a lot of differences, so pardon the list, but having been on a program during the cancellation of Constellation, being in Orion, seeing it from this side of the fence now is a little different. So we're going to stay, right? So that's one of the things that's been a clear message. It's not a camping trip that we're going to come back from and not go back, right? So we're going, and then we're going to stay. That leads to it's a proving ground as the next step for us to get to Mars, right? So there's a reason to stay and to use that as our proving grounds and testing grounds, because for all the labs that we're missing here on Earth now, for Mars we'll have the best lab, and it'll be the moon, right? Yeah. Other things are, we've got this diversity. Just look around the room, look online. Who do you have? You've got pretty much every sector, as was mentioned, LSIC's broad partnerships and membership, right? When we went the last time, that's not what we had. We captured the attention of the globe, but right now we are engaging the entire globe to meet this purpose. And so I think those are three big things for us that are different. And then right now the excitement's happening to where things are happening, right? Just today, we had an attempted landing on the lunar surface, right? And that's happening more and more frequently. And we're a part of that, right? And the folks that are tied into this and the folks you interact with, we're the ones that will be realizing the visions that are being talked about, so.
Fantastic. Tim, you have a hard act to follow, but you can take us home. We've had plenty of time to think about it, so.
So for me, one of the big differences is that our objective is to grow our activity on the moon and keep it growing so that we can accomplish these great science objectives, exploration, get ready for Mars, whole diverse set of activities. And because the point is growth, then we want an economy, we want commercial services, we want businesses, and we want the competition and collaboration all over the place. And so that growth really defines for me what the sustainable lunar economy is.
Fantastic. Let's thank our panel again, everybody. Really was wonderful. I know we didn't get all the questions, but we'll try to give them to you as well. For now, we've got a 20-minute break, and then we'll come back here with your thoughts. We'll have a little bit of discussion about the major takeaways before we adjourn. So see you all again at 4 o'clock.